Hello friends, in today's lecture we are going to see the nomenclature of heterocycle. As in previous lecture we have seen different heterocycles and chemistry of those heterocycles. So in this lecture we are going to see nomenclature of heterocycles. Initially we are seeing the nomenclature of heterocycle. In heterocyclic chemistry there is a special name for each individual ring system and a trivial name for each compound. So primary function of chemical nomenclature is to ensure that a spoken or written chemical name leaves no ambiguity concerning which chemical compound the name refers to. So each chemical name should refer to a single substance. So International Union of Pure and Applied Chemistry, which is known as an IUP. So in recent years, the International Union of Pure and Applied Chemistry has made effort to systematize the nomenclature of heterocyclic compounds. So according to this system, single 3 to 10 membered ring are named by combining the appropriate prefix or suffixes listed in table 1.1 and 1.2. So this International Union of Pure and Applied Chemistry, that is IUPAC nomenclature, is used for naming the heterocyclic compound. The purpose of the IUPAC system of nomenclature is to establish an international standard of naming compounds to facilitate communication. The goal of the system is to give each structure a unique and unambiguous name and to correlate each name with a unique and unambiguous structure. Types of heteroatoms. So the heteroatom type is defined by using specific prefix. The specific prefix is used to identify a specific type of heteroatom. And common heteroatoms are indicated by using the some prefix. So heteroatoms and their prefixes. So whenever you have an heteroatom, oxygen is present, then you have to give the prefix oxa. For nitrogen it is aza, for sulfur thia, for selenium it is selena, for T that is tellura. Like that you have to give the prefixes for the heteroatom present in an heterocycle. Then suffix. The ring size is indicated by using a suffix according to the table listed as follows. They are derived from Latin numerals, namely IR from tri, it from tetra, AP from hepta, OC from octa, etc. The endings indicate the size and the degree of unsaturation of the ring. The common name endings for heterocyclic compounds. So these are the suffixes which you have to give while nomenclature of heterocyclic compound. So suffix for fully unsaturated compounds and suffixes for fully saturated compounds, with nitrogen and without nitrogen. So whenever you have an unsaturated compound, you have to give suffix irine, that is IRINE, with nitrogen, and without nitrogen you have to give the suffix IRENE. Like that you have to give the suffixes for fully unsaturated compounds. Similarly, suffixes for fully saturated compounds with nitrogen and without nitrogen. For 3-member ring, it is iridine, that is IRIDINE with nitrogen, and irene, that is IRANE without nitrogen. Similarly, for 4-member ring, 5-member ring, then 6-member ring, 7-member ring, and 8-member ring. You do follow this table while nomenclature of the compound and while giving the heterocyclic compound. So according to this system, heterocycles are named by combining appropriate prefix or suffixes. The letter A in the prefix is omitted where necessary. oxirane. So this first structure is oxirane. Then this one is oxirane due to the presence of this double bond. Similarly, this is aziridine and this is oxetane. In all these examples, the letter A has been omitted. However, in the following cases, letter A has been retained. So this is very important rule you have to take into consideration while nomenclature of the heterocycle. Sometimes we have to omit A and sometimes we have to retain A in the nomenclature. So in this case, it is azacyclobutadiene. In this, A is retained. Similarly, in this structure, 2-oxabicyclooctane. In this also, A is retained. But here, in oxirane, A is omitted. So sometimes we have to omit A and sometimes we have to retain. There are a large number of important ring systems which do not possess any systematic names, rather non-systematic or common names are used for them. Some of such examples include the following, that is furan, thiophene, pyridine, then quinoline, indole, purine. So all these are common names for the heterocycles which do not possess any systematic name, rather non-systematic or common names are used. So 5-member ring with oxygen is named as furan. So this is a common name for this ring structure. Then this one is 1,2-isooxazole, then 4-methylthiazole, and this one is thyrene 1,1-dioxide. So there is yet another system of nomenclature for fused ring that is commonly employed. According to this system, the side of the heterocyclic ring is labeled by a letter A, B, C, etc. starting from the atom numbered 1. Therefore, side A being between atom 1 and 2, side B between atom 2 and 3, and so on, as shown below for pyridine. So this structure which contains heteroatom is numbered as 1. Then this position between 1 and 2 is referred as A. Okay, then 2 and 3 is referred as B. Like that you have to give the numbering from A, B, C, D, E, F, like that. So this is an example of pyridine. So the name of the heterocyclic ring is chosen as the parent compound. The name of the fused ring is attached as a prefix. So the prefix in such name has benzofuran. So in this case, this oxygen is numbered as 1. Then this 1 and this attachment is numbered as 2. Then the numbering, the attachment between 1 and 2 is known as an A. That's why this nomenclature benzofuran. So attachment of this one ring to another ring at B side. Similarly, benzo-B-pyridine. In this case, this number nitrogen is numbered as 1, then 1 and 2, in between 1 and 2 it is A, then 2 and 3 it is B, and at B side one ring is attached to another ring, that's why it is benzo-B-pyridine. That benzo is attached to pyridine at their B side. Similarly, benzo-C-thiophene. So these are a very important point you have to take into consideration while nomenclature of heterocyclic compound. Note, systems having a lesser degree of unsaturation require an appropriate prefix such as dihydro or tetrahydro. Then examples. So in this case it is oxa plus irene. So in this case it is oxirane. So A is omitted. Then here it is thia plus irene. Thia because presence of sulfur and because of the 3-member ring which is saturated. There is no any unsaturation, that's why it is irene. So it is thyrine. That's A is omitted. Then it is aziridine. Aza plus iridine. Then here it is oxetane. Because presence of 4-member ring, it is ethane. And from oxetane. For this structure it is thietane. Because thia plus ethane. For presence of sulfur it is thia, and 4-member ring, because of this it is ethane. Then azitidine, because aza plus ethidine. Then oxolane, oxa plus olane. Then thiolane, thia plus olane. Then last one is azolidine, aza plus olidine. So you have to consider this point when and second one. In case of substituent, the heteroatom is designed number 1 and the substituent around the chain are numbered so as to have the lowest number for the substituents. So for substituents you have to give the lowest number. So this point is very important. So examples under this point is 2-propyloxyrane. Okay, so at second position there is attachment. So if we are going to give the numbering as 1, 2, 3, then this is wrong numbering style. So you have to follow the numbering as per the note whichever I am given, that we have to give the lowest possible number to the substituent. So it is correct numbering is 2. It is 2-propyloxyrane. Then this one is 2-bromo-3-methyl-aziridine. In this case it is 2-bromo-4-ethyl-thiolane. So keep it in mind, while nomenclature you have to give the lowest possible number to the substituent attached to the heterocyclic compound. Then partial unsaturation. Use fully unsaturated name with dihydro, tetrahydro, etc. So in this case it is azepine. In this case it is 2,3 dihydroazepine, because presence of 2 hydrogen at second and third position. So 2, 3 and 2 and 3 hydrogen are present, that's why it is 2,3 dihydroazepine. Keep it in mind. In this case it is 4, 5 dihydroazepine. So here at 4 and 5th position there is an hydrogen atoms are present, that's why it is 5 dihydroazepine. So we have to number the carbon atom on which extra hydrogen is present. So this is a general structure for azepine, and these are the structure containing extra hydrogen atoms. So these are unsaturated and saturated forms of heterocyclic compound. So this is a special problem resulting from isomerism in the position of the double bonds, which is sometimes referred to as extra hydrogen, and this can be addressed by simply adding a prefix that indicates the number of the ring atom that possesses the hydrogen using italic capital 1H, 2H or 3H, etc. So you have to give the italic capital while numbering or while nomenclature of the heterocyclic compound. The numeral indicates the position of these atoms having the extra hydrogen atom. So in this case, this is structure of pyrene, but in this structure at second position there is one more hydrogen is present, that's why it is 2H pyrene. In this case extra hydrogen is present at this fourth position, that's why it is 4H pyrene. The saturated position takes priority in numbering, so keep it in mind. So this point, that is giving italic capital, is very important whenever you have an extra hydrogen atom. Rings with more than one heteroatom. Whenever you have a ring with more than one heteroatom, so two or more similar atoms contained in the ring are indicated by a prefixes di or tri, etc. So in this case it is 1, 3, 4 triazine because of presence of nitrogen at 1, 3 and 5th position. Similarly here it is 1, 2, 4 triazole. So if more than one heteroatom occurs in a ring, then the heterocycle is named by combining the appropriate prefixes with the ending in table 1 in the order of their preferences. Oxygen is more than sulfur than nitrogen. So the priority order or preferences is high to oxygen, then sulfur, then nitrogen. Thank you. The remaining part will continue in next lecture.